Right, okay, so we are going to talk today about the method of isoclines and gradient fields. Right, okay, isoclines and gradient fields. We didn't really cover this particularly well last time, I don't think. We sort of glossed over it a bit. So I thought I'd show you how to do this properly. It could come up in the exam. I've seen exam questions with this in. So it's used to solve this differential equation, which you're now familiar with. Okay? dy by dx equals some function of x and y. And the idea is, first of all, let's define what we mean by an isocline. So an isocline is, just one second. dy by dx is a constant. Okay, so an isocline is dy by dx is a constant. There's a special word or name given to when c equals naught. When c equals naught, the isocline is called, anyone hazard a guess? Anyone do computing and Java and know what we use for zero or nothing? Null. Come across that? Anyone doing programming? Null. It's called the nullcline. And if you're using temperature, it's called the Kelvincline. No, it's not. Sorry. Okay, so that's called the nullcline. In other words, dy by dx equals naught. Let's do an example of creating some isoclines. So here we go. Example. And the question says, for the following differential equations, this is question 2 on page 22. For the following differential equations, find the equation of the isoclines, and hence, by sketching these, construct the slope field, that's otherwise called the gradient field, by the way, and solution curves. Okay, so the first thing that we need to do is to form dy by dx equals c. So in here, our example is dy by dx, and our function of x and y is 2x minus y. Okay? And we're going to let dy by dx equals c. So we're going to say let dy by dx equals c. In other words, 2x minus y equals c. What does that look like? Of what type of thing does it look like? It's a straight line. Yeah, this is a straight line. So we're going to rearrange this now into something that's a bit more happy with that? Y equals 2x minus c. Right. So that's quite straightforward. So what we're going to do now is we're going to draw some axes and we're going to first draw the nullcline. So step 1, if you like, draw the nullcline. That says nullcline, which looks like what? Y equals 2x. So it's going to go through the origin, agreed? And it's going to have a gradient of 2. So we're just going to sort of approximate that. That looks like that. So this is c equals naught. Right, now if c equals naught, what is c? It's dy by dx. Agreed? That's what we said here. So this is an isocline, by the way. This black line is an isocline. What we're going to draw is the slope field on the isocline. And the slope field says it's the value of dy by dx. In other words, dy by dx equals 0 on that particular isocline. So how am I going to draw that? By just doing what? Dy by dx equals 0. What does that look like? The gradient is 0. What does the gradient? Horizontal line. So what we're going to do is we're going to draw little horizontal lines along there. This is the red lines are called the slope field. Okay? And now we're going to do another isocline. So we're going to pick, it seems sensible to pick integers, 0, -1, 1, -2, 2. So let's go to c equals -1. If c equals -1, what's our isocline equation? Yes, being very slightly careful there with our signs. Y equals 2x plus 1. And what does y equals 2x plus 1 look like?
Just that line that you've got drawn shifted, plus 1 up.
Yeah, it's parallel to that, and it goes through that point of 1 here. And what are my slope fields going to look like? It's got a gradient of what? 1. Yeah, so let's just make sure that we write c equals, what did I say? -1. So be careful, yeah? So this is -1, and my gradient of -1 looks something like this. Do you agree? Trying to make them as parallel as I can on the iPad. So 2 here would be c equals 0. 2 would be draw the isocline y equals 2x in this case. 3 would be, I'll do this in red so it corresponds to the red on the graph. Draw a gradient field, or otherwise known as slope field, on the isocline gradient 0, which is that 0 there. Okay, and then we did the same thing again. And then basically repeat for as many isoclines as we feel as though is necessary. So let's do c equals 1 now. Hopefully you can see what that looks like. So that's going to look like, it's going to go through there, trying to make this consistent as I can. This does not draw straight lines very well. It wiggles them for some reason. So this is c equals plus 1. And plus 1 gradient looks positive, sort of like that. Okay, let's draw c equals 5, I don't know, c equals 5, yeah, c equals 5, what do we get? Y equals 2x plus minus 5? Yes. So we're going to do c equals 5. Yeah, so it's going to be, let's do, it's not quite 5, so let's just say that's going to be 2. Let's might as well just do c equals 2. And that's got a gradient of 2, so we do a steeper gradient. It's going to be -2, isn't it, the gradient?
No, the gradient is going to be
c equals 2, that's right.
as the line.
Oh, it is, yeah, of course it is, yeah.
How would we draw that?
Just, I'll show you. Oh, I can't. Just along the line, basically. Yeah, so bring your coloured pens in. I'm just going to do that again up here. It is quite difficult on the iPad to do this, I must say. the gradient is like that. And we'll do one more. We'll do c equals minus 2. So this is c equals minus 2. And notice that in the exam you would definitely put these on here. Okay? Label them with your values of c, and you obviously use a rule, and you obviously try and get them parallel in this case. So c is minus 2, so we want a gradient of minus 2. So these are going to be at right angles, aren't they? No, of course they're not. They're steeper than that. Gradient of 2. Something like that.
That's positive, isn't it? Shouldn't be negative because c equals minus 2.
C is minus, yes, sorry. So C is, what have I just said? C equals minus 2. So it's minus 2, a negative gradient, yeah, negative gradient. Negative 2, there we go, negative 2 gradient, there we go. Yeah.
The gradient lines for c equals minus 2, do they go straight down, like vertically?
No, they're not vertical. It's just, it's very difficult for me to get any differentiation on the iPad between a vertical line and one with a gradient of 2. You can see they're just going to get steeper and steeper and steeper the more negative the isoclines become. And then, so you can sort of see where these curves are going to. They sort of kind of come down here and seemingly go back up here again. This sort of thing is going to happen. The solution curves, can you see that? Now remember, these little red lines are tangents. Okay? They're tangents. So, well, that's clever. I can just delete the blue. That's nice. I like that. So when we draw this, we want to sort of say there's a tangent. I can't quite do it on here. There's a tangent here. There's a tangent here. There's a tangent here. Tangent here. And you can sort of see what's going on. You're going to get these. And if these are tangents, can you see what's going to happen here? You're going to get an asymptote there for the solutions. Can you see that? And then they're going to get steeper and steeper and steeper and steeper up there. So I'm going to get this sort of family of curve that look like this for my solutions. All right? So these will be my solution curves. The black ones are the isoclines, and the red ones are the slope field. Should we do one more? I'll do it on the board this time. Okay, so let's look, for example, at 2c, part 1. So we've got dy by dx is 2x minus y squared. So what's the first step? Yeah, so we would say something like isoclines are 2x minus y squared is c. So, what's this going to look like? Let's rearrange it. We're going to get y squared is equal to 2x minus c. So we're going to get y is the square root of 2x minus c. Okay, so let's draw the nullcline first. So the nullcline is y equals the square root of 2x minus naught, which is of course just root 2x, which is actually root 2 root x, which is actually y equals root x stretched by a scale factor of root 2. So you should be able to see that if we draw some axes now, x and y, then this curve is going to look like, so I'll do my isoclines in blue, something like this. This is corresponding to c equals naught. Okay, so my isocline c equals naught, well, the gradient along that, the gradient field is naught, so I need horizontal lines along there. Let's now do the isocline for c equals 1. So for c equals 1, we're going to have y equals the square root of 2x minus 1. And that looks like this. Let's see, equals 1. And along that isocline, my gradient is 1, so I'm going to draw a gradient with slope 1 along that isocline. So now let's do the isocline relating to c equals minus 1, and that's going to look like that. And that's got a slope field minus 1, so a gradient of minus 1 looks like that. And now let's draw c, the isocline for c equals 2. So that's going to look like this. And my slope field on there is c equals 2, so it's going to be steeper again. Gradient of 2. And finally, let's draw isocline for c equals minus 2. And we have a negative 2 gradient, so that's going to be a steeper negative gradient there. Now, remember that these lines here, these slope field, are tangents because it's the value of the gradient. So if we pick a particular point, so let's do this in, say, green. If we particular starting point, let's say here, okay? So we're going to start there. And what we want to try and do is to draw the solution curve. If these are tangents, can you see that the solution curve is going to look like this? Okay? They're never allowed to sort of remember these are tangents. So if they're tangents, they need to sort of follow the horizontal line, if you like, as close as we can. And what's going to happen is that the solutions are going to be pulled in towards this idea. If we start down here, the solutions are going to go up like this and get pulled in towards there. Okay, if we start down here, then you can see if these are tangents, then the solutions are going to be pulled up this way. And there's a bit of theory that says, and this is important, that the solution curves cannot cross each other. So solution curves must not cross. I'm not going to go through the derivation of that at all. Let's just do one more of those so you can see. So if our solution starts off here, you can see that it's going to come in and going to go into here. So we can see that as x sort of tends towards infinity, we're going to end up sort of running along this line here like this. So just a quick recap, we take our differential equation, we state to the examiner that isoclines are when the derivative is a constant, so therefore we write our curve is equal to a constant. So once we've done that, the idea here is we're going to get some sort of curve resembling something that you know. Now, it might be an implicit curve or an explicit curve. So here we've written y explicitly in terms of x, and we get sort of our ability to sort of draw this with different values of c. But sometimes these curves, they might not be possible to write them explicitly. There might be an implicit equation from which you'd be able to recognize what these isoclines are going to look like. So that's what we're going to do next. We're going to look at an example. It's not from the notes, the book. It's one that I've actually got it from YouTube. It's a really sort of quite nice example. So let's look at that now. Okay, so we have this example, this differential equation, and there are two parts of the question. Sketch the isoclines for different values of the constant, -2 to 2, and then draw the slope field. Okay, so first things first. We know that isoclines are, the derivative is 0, so minus y over x squared plus y squared, equals a constant. There we go. So we set dy by dx equals a constant, and now we're going to rearrange this. So let's multiply through by x squared plus y squared. And we're going to rearrange this by multiplying out the brackets. And now we're going to put everything onto one side. So we're going to say that this is cx squared plus cy squared plus y equals 0. Now what we're going to do is divide both sides by c, leaving x squared plus y squared plus y over c equals 0. Now, hopefully you should be able to see that this is the form of a circle, but in order to get it into a more recognizable form, if you remember back from your GCSE days, we complete the square on the x terms and complete the square on the y terms. So let's do that. So you can see here that the x terms have already got completed square form. But the y, we halve the coefficient of y, square that, and then we subtract the square of this 1 over 2c. So, of course, we're going to end up with minus 1 over 4c squared. But I'm going to take that minus 1 over 4c squared to the other side and get that. Okay, well, what is this then? This is, as I said, an equation of a circle. So this is a circle, and the center of the circle is 0 minus 1 over 2c, and the radius is the square root of the right-hand side. Remember, this is x minus a squared plus y minus c squared equals r squared. So the radius is, of course, 1 over 2c. Okay, so what do they look like? Well, let's draw some axes. And now we're going to look at the nullcline, so that's when c equals 0. I'm going to be a bit careful here, because if you look here, if c equals 0, we actually don't get a circle, because having a a denominator of 0 here means there's no defined centre. And there's no defined radius either. So let's just go back to our original equation here, and we're saying that c equals 0. Well, if here we have if c equals 0, the only way that c can be 0 is if y equals 0. So y equals 0 is actually the null cline. Okay, so let's go back to our thing here, and we've got basically, let's draw our isoclines in green. So our isocline is going to be y equals 0. So here, this corresponds to our null cline, c equals 0. And what is the gradient at that point? Well, c, which is the gradient, is 0. So let's do our slope field in red. So actually, as strange as it is, our slope field is along here. Let's look for c equals 1 now. Okay, so for c equals 1, our circle is a centre 0 minus a half. So 0 minus a half, that's there. And its radius is a half. That's from here, putting c equals 1. So our radius is a half, our centre is minus a half, and that's, we're going to do our, we're doing our isoclines in green. So that's going to look like this, as the circle's centred that point there. And at that point, we're saying c equals 1, and therefore we're going to draw our slope field with a gradient of 1 throughout. Now, I'm trying to make our slope field consistent here. It's quite difficult on the iPad just to get that right. We want a gradient of 1 around this circle. Those lines are supposed to be parallel, difficult to draw, but anyway. What happens when c equals minus 1? Well, at c equals minus 1, we've got a centre minus 1 over 2 times minus 1, which is a half. So the centre is going to be a half, and the radius is going to be 1 over, so that's going to be a minus a half. That doesn't make any sense. But remember, actually, that my radius is plus or minus here, because it came about by square rooting this here. So I'm going to take the negative one of that, and so therefore my radius is actually a half. So I'm going to get another circle. This is a half, and my circle is going to look like that. And at that point, c equals minus 1, so I'm going to have a minus 1 gradient running around that circle there. They don't really look like. Gradient minus 1, excuse me. Try my best. Right, okay, so let's now have a look at c equals 2 now. Let's just label that one. This is c equals minus 1. So c equals 2. Well, at c equals 2, centre is minus a quarter. Hopefully you can see that. So that's there, and minus a quarter. And we have a radius of as a quarter. So we're going to get a smaller circle there. And the same is going to happen up here. We're going to get we're going to get a circle like that. And on each one of these, our slope field for this one was, so this line down here, this circle here, we had c equals 2, So our slope field is gradient 2, which is, again, quite difficult to draw on the iPad, apologies. And this is going to be minus 2 here. Oh, make them parallel, wild. Okay, there we go. Well, so what do the solution curves look like? Well, I'm going to draw the solution curves in blue. So let's take a point, let's say, starts up here. This would be sort of an initial point, x0, y0, and see what's going to happen. Well, hopefully you can see that the curve's going to sort of come down like this, and it's going to get pushed down by these tangents, and then it's going to, these are tangents here, so there's going to be an asymptote there. Okay? The general sort of idea is that the curves are looking like this. If I've got a point up here, then the solution curves are going to look like that. Never make these solution curves cross. They should never cross. Okay, so that gives you an idea about how to draw isoclines and the slope fields, and hence the solution curves.